Okay, this video is for Math 70, and this will cover the material on factoring out a greatest common factor. So the idea of factoring is similar to what we do when we break a number up into factors. Like if we have 20, we can split this as 2 times 10, and then factor the 10 as 4 times 5. So we're going to be doing the same thing, or a similar thing, with algebraic expressions. So we talked about how when you're distributing to multiply, let's say you have something like 3 times 5x minus 7, you distribute the 3 inside the parentheses, and you get 15x minus 21. So factoring out a greatest common factor goes backwards. We start with an expression like this, and we go back to the factored form, okay, with the parentheses, with the common factor outside. Let's see here. So we also know that, let's say, if you have 3x times 5x minus 7, then this will be 15x squared minus 21x. And so in this case, you have a common factor in the coefficients of 3, but then you also have a common factor in the variables equal to x. Okay? All right, so let's take a look at some examples and talk about how to do these problems. So they'll start out pretty straightforward, and then they'll get more challenging. So, problem 2, we have 14x plus 21. So again, what we want to do is we want to look at the coefficients and see if we have a common factor there. If we do, then let's factor it out. So we have a common factor of 7. And so if we pull out the 7, where this is 7 times 2, that'll leave us with the 2. And since this is 7 times 3, that'll leave us with the 3. Okay, and the x just stays the way that it is. So that's a pretty straightforward one. We just had a common factor of 7, and so that gets factored outside of the parentheses, and then the 2x plus 3 is inside. And you can always double check by multiplying back through and making sure that you end up with what you started with. Let's see, problem 6. We've got 9x minus 12y. So again, look at the coefficients, the 9, there we go, the 9 and the 12. They have a common factor of 3. And that'll leave you with 3x in the front and 4y in the back. Okay. Let's see here. Problem 8 is very similar, except that there are 3 terms, 2x squared plus 8x plus 4. And so here we have to look for a factor that's common to all 3 coefficients. And in this case, again, it's relatively straightforward. We've got a common factor of 2. And so after you factor that out, we'll be left with the x squared. Here we'll have plus 4x, and then here plus 2. All right, let's see what else we got here. All right, well, starting with problem 11, they get a little bit more challenging. So let's look at problem 12. We have 7x to the third minus 4x squared. Now in this one, there's no common factor between the 7 and the 4. But we do have x's in both terms. And we want to pull out as many x's as we can. So this one has an x squared, and this one has an x cubed. Now, since this only has a squared, we can't pull x to the third. We can't factor x to the third out from both terms. But we can factor the x squared out. Okay? So here, that'll leave us with 7x to the first. And then here, just the minus 4. And again, we can check it by multiplying back through. There's our 7x to the third. There's the minus 4x squared. All right. Let's see here. All right, 14. Well, this is, I think, a really good problem because it's not trivially easy and also not impossibly difficult. So, we want to look for common factors in both the coefficients and in the variables. So there's the coefficients and there are the variables, all right? So we've got a common factor of 5 in the coefficients, so we'll factor that out. And then just like we had in number 12, we've got a common factor of q squared in both of them that we can factor out. Now notice that I've factored out both the 5 and the q squared, so it seems like there's nothing left. But if you remember in one of those first examples I was doing, you know, I factored out the 7, and so here the 2 was left and here the 3 was left. Now, this is 5 times 1. So when I factor out the 5, there's still a 1 there. All right? Here we'll have a 2, and we'll also have a q to the first power. But it's really important that if you're factoring and you factor out the entire term there, you're going to have a 1 left. All right? And so that way, again, take a look at what happens when we multiply back through. There's our 5q squared. There's our minus 10q to the third. If we didn't have that 1 there, we wouldn't get this 5q squared back. Okay. Let's see here. Problem 16. 30 ab squared minus 25 a squared b. Okay. So it looks like we've got a common factor of 5 again in the coefficients, and then they both have a's and they both have b's. So let's take each one individually. So here we've got a common factor of 5. Okay. This has an a, this has an a squared. So the most we could factor out is just that a to the first. And same thing with the b's. This has a b, this has a b squared. So the only thing we can factor out from both of them is the b to the first power. So what's left? We're going to have a 6 here. We factored out the a, and one of the b's is going to be left. All right. Here we'll have a 5. We factored out one of the a's, so one of them is left. And we factored out the b, and so that's going to be it. All right. So they're starting to get a little bit trickier now. Here. Yeah, problem 18 is very similar. Got 27x to the third y squared plus 9x squared y. And so we're going to do the same thing we did in problem 16. We're going to look for common factors in the coefficients and the variables. So here we've got a common factor of 9. Here in the x's we can factor out x squared, and in the y's we can factor out the y to the first. The greatest common factor in the variables is always going to be the lowest power that you've got, or the smallest power of the variable that you have. So here it was the x squared, here it was the y to the first. Okay, now what's left? Well, we factored out 9 from the 27, so that'll leave us with a 3. We factored out x squared from x to the third, so that leaves us with x to the first, and same thing with the y's. We factored out y from y squared, and that leaves a y there. Now here, we factored out the whole thing. That's like that problem that we just looked at a few minutes ago. We factored out the 9, the x squared, and the y, but don't forget that this is 9 times 1, and so when you factor out the 9, you're left with the 1. And the same thing is true of the variables. If you had a variable there, you would still be left with the 1. So like if you had 5x squared plus x, and you wanted to factor that x out, okay, when you do that, you'll be left with a 1 in that position. Okay. All right. Let's look at a couple more here. Let's see. Well, let's look at 24. Here we've got 5xy squared, 10x squared y squared, and then 15x squared y. Okay, so in the coefficients, we've got a common factor of 5. In the x's, they have all got an x, and the biggest power we can factor out is the x to the first. Same thing with the y's. We can factor out a y to the first here. Okay, so if we've done that, the only thing left here will be y. We factored everything else out. Here we factored out the 5, so that leaves us with a factor of 2. And we factored out 1x and 1y, so that leaves an x to the first, y to the first. Here we'll have a 3 and an x, and the y got factored out. Okay? And again, you can always double check by multiplying back through and making sure that you get what you started with. Okay, let's see. Let's look at one more here. Problem 26. 20, a to the fourth, b to the third, 18, a to the third, b to the fourth, and 22, a to the fourth, b to the fourth. All right. So, let's see. We've got a common factor in the coefficients of 2. That's the biggest one, really, that we can factor out. And here we've got a to the fourth, a to the third, and a to the fourth. So we can factor out a to the third. And same thing with the b's. These are b to the fourth, but this one, the b to the third, means all we can factor out is a b to the third. So what's going to be left? Well, we'll have a 10, and then a to the first. Okay? And then minus 9, b to the first. And then plus 11, AB. And again, if you multiply back through, we'll get what we started with. Okay, so that's it for this assignment. If you have any questions, please let me know. And in the next video, we'll take a look at a different kind of factoring. Thanks.